Hi, everyone. Welcome to today's Meetup/Elastic live stream on the Elastic Community Channel. Today we have Kirk Kolzer, who is an Elastic security curriculum developer. He's joined by Sean Cochran, and who is also on the Elastic Services team. And today they're going to be talking about a project that they work on called Thremulation Station. So without further ado, I'll hand things over to you, Kirk.
Hi, my name's Kirk. Just a little bit about me. I'm a family of three, and we live in Missouri, north of Kansas City, about an hour. I've done 8 years of active duty Air Force. The rest of my, so far, 18 years has been spent in the National Guard. With the last 4 of those spent with the Missouri Cyber Team and being a technical advisor for NGB for a concept program for critical infrastructure. On the civilian side, when I'm not doing military stuff, I have spent time working in power generation and a fiber telecom business owner, and all of that centered around software development, geospatial, and sysadmin things. The stuff I do at Elastic is mostly centered around curriculum development for some of Elastic's security courses, mostly focused around the Elastic network security. When I'm not doing that, I'm building DevOps pipelines and creating updating content around said security courses. I can include my LinkedIn profile at the end of the thing if you guys want to contact me on LinkedIn. I love talking about this thing. I love talking about security. I'm very passionate about it. And I'll drop that link in the chat at the end of the webinar today. So what is Thremulation Station, and what's the problem it's trying to solve? And the biggest thing is we wanted to have something easy for us to stand up to see what evil looks like in Kibana, and use it as a kind of a troll-free learning tool and training tool for our airmen and soldiers, and then folks that don't fit into those two categories. Kind of a few examples of the uses we came up with Thremulation Station was just to generate some cyber defense education and training data. And then also use it to do threat intelligence training because it gave us realistic looking threat actors via Caldera. It also has the benefit of helping us write and validate detection rules in the Elastic detection library. And I'm going to go ahead and drop a link for that right here. And it also helps us work on the writing and testing threat techniques that are aligned with the MITRE attack framework. So to kind of give you the left and right bounds of what's going on with Thremulation Station, it is a semi-sandbox environment. But it does open up ports on your local host, so we can reach Caldera and the Elastic components. Another thing is it shares a lot of the same infrastructure. I will be going over the diagrams here in a little while, and I'll show you kind of where things are shared. So like the attack and collection interfaces or infrastructure are on the same box. The other kind of thing is this is a pretty resource and bandwidth intensive process. We tried to automate as much of the build process as we could. That being said, it still requires a fairly decent internet connection to download the boxes, and then decent hardware somewhere in the realm of 4 cores and 8 gigs to run it. And then Windows 10 is an evaluation copy, so we have the limitations of that, and that mostly just centers around it will only stay up for 1 hour before it shuts off, because it's an evaluation copy. So Now that I kind of gave you the left and right bounds of where we're at, I want to give you an overview of actually what we're talking about, and that's Thremulation Station. I'm going to step through kind of GitHub and documentation and Slack. And if my screen is up, you'll notice that it says Discord on that. This is kind of peering into the future, but we're moving things from Discord into Slack so we can interface with the community a little bit easier. So if you're wanting to see all things Thremulation Station, we have shortened it as much as we can to try and get the point across, but it's at thremulation.io. And from there, you'll see this awesome logo that Sean and somebody else came up with for our awesome project here, and gives a brief overview of what's going on and how it works. The big things I'm going to focus here on are the GitHub and the documentation. So first things first, let's look at GitHub. And here you can see it's your pretty standard GitHub repository. We've created an organization around it, and you can sit, if you have any issues with Thremulation Station or want to make any requests or anything like that, be done via the GitHub page. It'd be the easiest way. Otherwise, Slack is an awesome avenue to talk to us about Thremulation Station. While I'm here, to make things easier, I'm going to go ahead and copy the Git repository because we're going to use that here in the future for deploying Thremulation Station. So I'm going to need that. And that kind of brings me to my next point, is how to deploy Thremulation Station. So let me make this a little bit bigger so everybody can read that. When you click on the docs, you land here, and I'm not going to go into the docs all the way. I'm going to kind of hit the high points here. I've got quite a lot of stuff I want to show, and only so much time to show you. So the big things I want to highlight here are the quick start guide, which goes over the installation of Thremulation Station. And we've taken the time to go through the dependencies for each one of the, or for several major OSs, for Mac, Windows 10, and CentOS and Fedora. They're all relatively the same. We do recommend using Homebrew for macOS, or using Chocolatey for Windows. It makes the installation process a lot easier, a lot more predictable. For us, if we have to troubleshoot it or help somebody, it makes it a lot easier for us as well. And you can see that there is a pretty verbose list of topics here, and we kind of walk you through it without going into the rabbit hole that is make docs. The last two things I will go over are the support and reference section here at the top, the tab up here, and that will point us to our external references. An entire class could be taught on just the red team stuff. But we're going to take a small little trip in there, but we're not going to, I'm not going to teach you an entire Caldera or Atomic Red Team class. This will be an exercise left up to the reader, as well as any of the common Elasticsearch documentation is here as well. If you get completely lost and don't know where to go, MakeDocs has a wonderful section centered around, or a wonderful option for searching. And I'm going to go ahead and search Caldera, because this is a webinar. It's going to kind of focus on Caldera as well. and I'm going to go ahead and search on that, and then it will bring up the usage guide for Caldera. And you can see it's pretty exhaustive and has quite a few sections to go over Caldera. So that finishes out that. I'm going to drop the link for the Slack channel. Feel free to join the Thremulation Station Slack to talk with us and come up with ideas. At the end of the webinar, I'll kind of go over what we plan on doing in the future with Thremulation Station, some of the ideas we've come up with, and how we're going to accomplish those. So this is going to be fairly high level. So I'm just going to kind of go over some diagrams real quick to show you where we are, to kind of give you our terrain, what it looks like on the inside of Thremulation Station. So I'm going to start with this right here. We have 3 boxes. I'm only going to deploy 2 for this webinar for the sake of time, but I wanted to make sure that everybody was aware that there's multiple boxes for this. Big things to note here is they're inside their own private network, and the IPs where everything's located, because this is going to help us later when we RDP into the Windows box and SSH into the Elastic box to run Caldera. All right, so to kind of describe what we've got here, we've got Atomic Red Team, and Caldera is kind of our attack infrastructure. Atomic Red Team is a collection of commands focused are aligned with the MITRE attack framework. If you want to look a little bit more detailed into some of those, I'll go ahead and share that link. In this case, we're going to focus on the Windows Atomic Red Team stuff. And let me back up here a little bit. As you can see here, it's organized in folders. I'm looking currently at the Windows Atomic Team tests, and then they've got it organized by tactic and technique as far as each step in the framework. So you got credential access. If I scroll down a little bit more, you have collection, and so on and so forth. I'll kind of show you where this pops up in Caldera later. But so you kind of understand what's going on, is these tactics are pretty verbose in their documentation, and it gives you basically each one of the tests, and if there's any kind of requirements or inputs that are needed. It gives the shell command, or the shell or PowerShell or CMD commands that it's going to be running for the Atomic Red Team. That kind of moves us over to Caldera, and Caldera is basically an automated red teaming platform. In our context, we're using it to generate kind of predictable data in a lab environment, so we can use that for training and threat detection, and CFAR rules will actually fire. So that will reside on our local host, and it is NATed to port 8888, and we'll access that here in a moment. Another thing to keep in mind is we actually have Fleet running as well, controlling the agents on the Windows and CentOS boxes. We'll take a small trip into Fleet here in a second, so we can allow, so we can keep the detection engine from actually preventing anything, because we want to see the full picture. We want to let Caldera do everything it's supposed to. And then finally, we have our Kibana user interface, and that will be port forwarded to 5601. Before I forget, I'm going to go ahead and, if anybody's not familiar with Fleet, I'm going to backtrack a little bit here and drop the kind of overview of Fleet and why it's useful. It was a beta feature, which is what this is currently deployed as. It's currently 7.12. And 7.14, it becomes its own server, its own dedicated infrastructure. So some of the things you see in here today will probably differ a little bit than from 7.14, which is currently out. All right, so let's actually deploy something. So I'm going to start my boxes here so they are ready whenever we are. And then I'm going to step through stationctl and try and make things easy for everybody. So getting started, if you look at the documentation, it goes into a very detailed guide on installing Thremulation Station, what dependencies you need. And basically, kind of the long and short of it is have Brew or Chocolate installed on Windows or Mac. You need a Vagrant along with the Vagrant disk size and VB guest plugins installed. You will need VirtualBox. You will need Git to clone down the repository. And then you will also need RDP to make any changes to Windows or any kind of user inputs. Well, that's not a hard and fast requirement to have RDP. It's definitely kind of necessary if you especially wanting to use Caldera. So first things first, as you know, we copied that Git repository. When I step through the Git page, I'm going to go ahead and do a Git clone. And I'm going to paste in the not the guide. It was very good. There's not a Git repository there. 1 second. Let's put it back to this and get the correct URL. Sorry about that, guys. I promise I practiced this. So there's our GitHub repository. I'm not going to go ahead and hit enter because I've already got everything set up. So at this point, if I hit enter, it would do a git clone. I already have that. So once it's done, finished cloning, it's going to create a folder called Thremulation Station. Let's see if I can make this a smidge bigger. Make sure everybody can see it. So to kind of give you an idea where I'm at, I'm in my default user directory on my Mac. I'm going to change directory in the Thremulation Station using a little tab complete. I'm going to enter. So now you can see if I do another PWD, which tells me where my present working directory is, you can see I'm inside of users, Kirk, Thremulation Station. And I'm going to do a quick ls. That's going to list the contents of this folder. And you can see we've got a few markdown files, a license file, a folder with images, Packer, and Vagrant. For this webinar, I'm going to mostly focus in Vagrant. If you want to kind of get into how we build everything, that's no secret. It's right there in Packer. But for the sake of this webinar, we're going to spend our time in Vagrant. So I'm going to do a quick CD into Vagrant and another ls to list what's out there. You can see there's a few things in here. Now, the two things I want to talk about here are stationctl and then Vagrant, which has to deal with the Vagrant file. I'm going to go ahead and start with stationctl. And we created stationctl as a kind of an easy way for beginners to start using this. They may not have a lot of infrastructure experience or experience with building ranges or sensors, but they want to learn threat hunting and they want to do threat hunting. So we have taken great pains to try and automate as much of this as possible while trying to keep things flexible with the hardware that is provided. So /stationctl and enter, you're greeted with this pretty looking text-based user interface. I'm not going to touch on every option in here, but I want to kind of overview a few of them so we can get people using this. Setup is pretty experimental. I've already done all the dependencies and I outlined them earlier. That's an automated way to set it up. It's still kind of experimental, but we are concerned about deploying it. So I'm going to hit option 2. And it's basically gives you 3 options here. There's a quick deployment, which basically downloads the ISOs, if you want to, so to speak, and deploys and provisions them and starts all the services, and you're ready to go. Elastic's already started; that's already enrolled in Fleet, and you don't have to do any of the infrastructure stuff at all. The next option is a custom deployment. You can basically choose the boxes you want. In this one, I'm only deploying the Elastomic box, which is required because it's basically the attack and the collection infrastructure. And then you can choose whether you want to deploy the Windows 10 box or the CentOS 7 box or both. Again, I'm only going to be using the Windows 10 box for this webinar. So you can use that option. It basically steps you through all of them and asks you questions to what you want. And when you're done, it'll deploy it for you. The third and final option here is downloading the boxes. Sometimes you're presented with a situation where you don't have internet. And as I mentioned before, this is a fairly bandwidth intensive process, downloading the images to deploy with. In the realm of gigs. So if you want to download these from home and then take them to your place of work and deploy them there so you're not chewing up precious bandwidth, waiting on them to download, you can do that as well. So that's option 3 for the stage deployment. I'm going to go ahead and go back because I don't need to do any of this right now because I've already got it deployed on my machine. The status page will show you the status of the current deployment. So it looks at it queries VirtualBox and says, hey, are these boxes up? Are they deployed? And for the Elastic portions, it will query your Elasticsearch cluster to ensure it is up and that is working. And then I also ensure Kibana is working. The last option I'll go through here on the main menu is the management option. The first 5 are pretty self-evident. The ones that kind of are a little bit more nuanced here are the last 4. Clearing data, it will delete the indexes in Kibana that are associated with your log data. Now, it won't delete any of like the Kibana user interface indices or any of the hidden indices or fleet or anything like that. It leaves those alone. The next option, soft reset, reverts your box to the states they were when you first deployed them. So after you've done a deploy, the first thing that happens or the last thing that happens before it considers it done is it takes a snapshot of the completely installed and provisioned boxes so you can revert later if you have an issue or you're wanting a clean slate. even more of a clean slate than deleting on just the Elasticsearch indices. The last two are more for troubleshooting, and they are for destroying the VMs. So if you've done something to your VM and you're not able to use them at all, doing a hard reset will destroy the VMs, but not the ISOs used to create them. However, option number 9 will destroy both the VMs and the boxes that created them, and you'll basically have to download everything from scratch. So that being said, I have exhausted all the options inside of Thremulation Station. This is kind of the beginning guide. If you have no idea how Vagrant or any of that stuff works, this takes the difficulty out of that. However, if you are more comfortable with Vagrant, we have a Vagrant file here, and you can do something as simple as Vagrant up, and it will deploy, if you spell it right, it will deploy a cluster for you. Now, I'm not going to hit enter because I've got one running right now, and I don't want to nuke it. So there's also a handful of other commands, especially if you're starting to use Caldera, that you're going to have to worry about. So if you consult the Vagrant command line interface docs, which I'm going to go ahead and drop here, that will help set things up for you. So you guys have had me describing what everything is going on and how to get this set up for the last 20 so minutes. So how about we actually fire stuff off at our and see if we can pick it up in Elastic. So how we do that is, first we need to get Caldera up and running. So if we go back and consult our wonderful diagram here, you can see is that it's on .10 and it's part of the Elastomic box. So I'm going to use Vagrant to SSH into that box. So Vagrant SSH, and it's going to be everything is got a prefix of TS. If we're doing dev boxes, it would have dev, but we're not worried about that. So we're going to do TS Elastomic, and we're going to SSH into it. So once that's completed, you may have to answer yes for fingerprints and then put in passwords. All passwords and usernames are either admin or vagrant to keep things simple. It's not the most secure, but again, the intention is this to be in its own little environment inside your laptop and not exposed to a production network. So as you can see, I have changed my shell has changed a little bit. I'm going to do a quick PWD to show where I'm at. So I'm in the Vagrant users home folder, and if I show where I'm at or show what's in here, as you can see, there's stuff for Atomic Red Team, Caldera, and a few other stuff for deployment. We're concerned about Caldera. So we're going to do a CD to change directory into Caldera, if I can spell it right, and a quick ls to show what's in here. Now, Caldera does not start by default. These boxes are pretty narrowly provisioned, so there's not a ton of resources there. We want to try to keep it fit inside of a laptop. So we leave some things off by default just to make things deploy faster and run better. In this case, I want to deploy my Caldera server. So I'm going to type in Python 3 space server.py space tac insecure and start my Caldera server. I already have the server started, and And I can see that by doing a quick SSLNT, or it's not started. So let's go ahead and start it. And now it's going to run through all of its tasks, and then it's going to tell you it's ready. So once we've got this point, we have Caldera started, we can start using our web interfaces. Before we start on Caldera, I want to make sure that Elastic is not going to stop anything that's going on. So first thing I'm going to look at is the web UI for that, and that's going to be on localhost 5601. And the username is going to be Vagrant, and the password is going to be Vagrant. I know it's insecure. And then from there, I'm going to go to my security app. And I'm going to scroll down and go to administration. And as you can see here, I have only the one endpoint activated right now. And I need to make changes to it to stop the prevention side of the Elastic agent. So I'm going to go and view agent policy. And then I'm going to further go into the endpoint policy and edit that integration. And then one further menu in, I'm going to edit the actual policy for the endpoint security integration. By default, it's set to prevent. I don't want to stop anything. I'm not trying to validate detection rules and see if they actually catch and prevent something. I want Caldera to run, throw the kitchen sink at it and see if it catches everything in the detections app. So from there, I'm just going to go ahead and select detect, and then I've already saved it. So, but I'm going to go ahead and click save again. It'll ask you if you want to deploy changes, and you say yes. So the endpoint is not going to stop any changes. It's just going to detect them and say, hey, I found something. I'm not stopping it. So now that we have that all ready to go, we can pivot to our Caldera dashboard, which is thankfully a very easy easily navigated URL. It's on our local host, and it's on port 8888. So there's a ton of options in here. The three I'm going to focus on here is the agents, adversaries, and operations. Before we do anything, we need to be able to talk or have an avenue for Caldera to talk to Windows. So we need to deploy an agent on there. And this is different from the Elastic security agents on there. This is of course, it logged me out. This is different from the agent that's on there for our security solution. This is attack infrastructure placed on the box. So it's pretty straightforward. In our case, we're going to click here on deploy an agent, and we're going to choose the Golang based agent here. And thankfully, we already know our infrastructure. Our target is going to be a Windows box, so we're going to filter that down to Windows. And we also have the benefit of knowing where the IP is, and we can see that both our attack and detect infrastructure is on Elastomic, and so we want to use that as our C2. So if I go back to the dashboard for Caldera, I'm going to type HTTP //192.168.33.10, and this is inside that NATed network inside a VirtualBox, and I want to pass it the port of 8888. and that's talking back to Caldera. So thankfully, it's given us a nice little string of PowerShell to copy and paste into here. So I'm going to go ahead and copy this. And then I'm going to bring Windows Remote Desktop. Now, I already have mine saved here, but it's under the IP of .11. If you consult the diagram, you can see that. I'm going to go ahead and start it. Username and password, again, Vagrant. And continue. It'll probably ask you about a certificate if you're using the Mac version. And I am going to not make that take up the whole screen. All right. So while that's logging in, first thing I want to do is open a PowerShell command, because that's what Caldera has given me for putting an agent on this box. So I'm going to open up PowerShell. Let me do it as an administrative user. And once it loads, give it a few seconds here. I'm going to go ahead and right click, and that's going to paste it in there. So thankfully, I didn't have to type all that whole mess in there. Once I'm sure everything's made it in there, I'm going to hit enter, and it's going to deploy the agent on the box. So we'll wait here a quick second while it does that. And now I'm just waiting for the agent to show up. Please, demo gods, don't fail me now. Okay, so once the agent's deployed, it will show up here. So now you can see that we have our Windows 10 agent, and the big thing to note here is that it has elevated privileges. When you're done, if you want to destroy the agent, all you have to do is hit the little X right there, and it gets rid of the agent. So that takes care of the agents tab inside of Caldera. I'm going to do a quick little trip into the adversaries tab. You can select from some existing profiles. For this webinar, we're going to use the You Shall Not Bypass one. And but you can add and modify these as you wish, and save them as a unique profile to drive home a point, or add some more context to a threat actor here. So if you do a quick little trip into one of the into one of the actions here, you'll notice that, especially if you're familiar with Atomic Red Team, you're going to notice that the technique ID is there, as well as the MITRE attack framework tactic that they have here. If you scroll down a little bit further, you can actually see and modify the command for Atomic Red Team, or excuse me, for Caldera to run as part of this campaign. And you can set timeouts and save it. I'm going to use just a pre-baked one for this. If you mess something up and don't know what to do, again, you can just reset things or X out of it. I'm going to use a pre-built one, so I don't really need to save or delete any kind of profiles or anything like that. So I'm going to go ahead and exit out of this one, and then I'm going to look at an operation. So as you can see, there are if you have an already built operation, you can view it here. We haven't created one yet, So I'm trying to make this a little bit bigger. You guys can see it here. I'm going to go ahead and add a new one. And I'm going to call it you shall not bypass version, let's call it version 2. And so that gives us our next set of options. We want to use our red infrastructure for this. That was created whenever we created our PowerShell command in Windows, and so we don't need to create any other ones. If you want to, like I said, we could create. You can do a whole class on Caldera by itself. We're not going to do that here. We're going to use the pre-built "you shall not bypass," and then the next option is basically how long you want for this operation to run. In our case, we want it to stop whenever we're done executing. We don't want to keep things open. We don't want to keep any of the C2 open. So I'm going to tell it to close when it is finished. And then I don't want it to pause. I want it to run immediately. And I want it to run autonomously, which is under here. And I'm going to go with the default stealth and jitter obfuscation settings here. And I'm not going to schedule anything because I want to run it now. So just a quick check to make sure my boxes are still running. They are. I'm going to go ahead and hit start, and it's going to start executing that operation against my my Windows 10 box. So from there, we can look at our Elastic security dashboard and start to see logs coming in. So if I go back to localhost on 5601, and I go back to my security app, and overview should do nicely. As you can see, it's already started firing off. I'm going to do the last 15 minutes because I want just the data we're looking at, just the data we're doing right now. As you can tell, it's still running here in the background. So not everything is here yet, but it's getting really close because there's 4 steps to this attack. So from here, I'm going to go ahead and refresh it so I can get the data I was looking for. Okay. So it looks like we've got a couple different things here, and you can see that it's generated quite a few logs, and it's generated, more importantly, some detections. So if I pivot over to detections, I have all of my detections turned on. You can manage those detections under Manage Detection Rules. I basically filtered by the tag of Windows and turned on all of the detections for Windows because that's the type of box that I'm using. So I'm going to back out of that and go back to the actual detection. And I'm sorry if this is a little big, a little bit smaller. So you can see that it's added these detections into basically a filter. And this filter shows in our security app basically what's going on from a response perspective. It's showing the open and in progress and closed cases. So one thing we don't want to do is waste effort and analyst time by having 2 people try and accomplish the same thing. So I'm going to go ahead and choose the malware detection alert we have here. And I'm going to go ahead and move it to in progress. So now that tells somebody else that it takes it out of the queue and tells somebody, hey, somebody's already working on this. I don't need to worry about it. You're good to go. So from here, I can get a little bit more granular. I can open up the detection log and see exactly what's going on. As you can see here, I've pinned the columns for the IPs and an MD5 hash because that's an artifact I felt was important. You can also see a process tree of what is going on with this particular event by clicking on the octagon there and zooming out. And from here, you can see that there was a whole tree of things that happened, the timeline, what they happened, and what spawned what, and the different logs associated with those processes. So you can see that PowerShell spawned other things as well. So I'm going to close this analyzer. And I want to start working this issue and try and figure out what's going on here. So I'm going to make this a little bit cleaner to look at. And I want to take some information and make it useful. And so what I want to do is I want to create a timeline. And so if I take, we'll just use the MD5 hash as an example. I can grab it and drop it here in my timeline. Now that I have a bit of information, I can use timeline to basically search across all of the different things and say, hey, have I seen this MD5 hash somewhere? And if I have, where have I seen it? And what category did it come up under? And other useful bits of information. So here, I'm just going to go ahead and create a timeline. So we're going to say workshop timeline. And we'll just call it test. Nice thing here is it gives us some notes to go over or to add some just context to what's going on. So if we do any kind of markdown based syntax, we can say, hey, let's set this to, let's say it needs to go to virus total, for example. And you can say, I have a hash that needs to go to MDT. And if you want to make sure it looks pretty, you can do the preview. You can add a note, and you can add more notes if necessary to add greater context to what's going on. So now I've kind of said, okay, I think I've got enough here to create a case, and I need to get folks involved. I've started to build that timeline of what's going on. I want to attach this to a case. So from there, I can pivot over to the gear in the top right-hand corner and attach this timeline to a new case. I can give it a name. We're just going to say newest case here. And we can give it all kinds of tags. I saw Splunk D in there. We're just going to use that as an example of a tag. And then the nice thing is it took our timeline and it dropped it right in the description for us to use in the future, so nobody has to go hunt to find out what I was looking at and what I was trying to say here. Another really useful thing here is the connectors. These connectors can reach out, for example, to Jira. And let's say the IT team is not part of the hunt team, and you need to isolate an endpoint. You can have an external incident management system tell your IT team to say, hey, we need to isolate this box. We need to pull it off the network. You need to unplug it and bring it to the security team so they can take a look at it. I don't have any connectors installed, so I'm just going to go ahead and create the case. So as you can see here, here's my case. Again, I can add more markdown and timelines and more information to add more context to the case and hopefully remediate it as fast as possible. So I'm not going to close it quite yet because I want to show the cases interface. The nice thing is you can break it down by open and closed. As you can see here, I have two other investigations that I'd done earlier, and I've since closed them. You can do it inside the case, or you can do it from here. In this case, I'm going to go ahead and close this case because I've solved the issue. I've remediated. We've pulled there's not really any intelligence value by keeping it on the network. So we yanked the machine off the network and we wiped it. So I can go ahead and close this case because IT's got back to me and said, hey, yeah, we're just going to give them a new machine. So I'm going to go ahead and close the case. And then once I'm done with that, I can go ahead and go back to my detections and close that as well. And say, hey, I'm done with this one. Nobody else needs to worry about it. And I can close it. So nice thing is all this data is captured in a much more granular and detailed view inside of dashboards. This is fairly high level, and you're looking, this is kind of the context you're gathering from an 80,000 foot view. You're looking at all your endpoints. Maybe we want to get a little bit more granular and see the actual log for what we're using. So we can go ahead and use a dashboard for that to zoom in maybe from 80,000 to 40,000 feet and look at an overview of the event logs generated by Windows. And as you can see here, I've got all kinds of different ones. But let's say I want to focus on the security logs. I can zoom in a little bit more using Kibana and filter out just those security logs. And let's say I know which event ID I'm looking for. I can further filter on that as well. So if I zoom in, you could say, okay, well, 18 is a much more manageable number to go look at individual logs. So I'm going to go ahead and pin those, and they will persist across all the different apps in Kibana. In this case, I want to see the individual logs. So I'm going to go to Discover, and I can see within the last 15 minutes that are using this there are a security log with the event ID 4689. I can see the actual log generated, and then I can basically use that to add more context to my timeline as well. So I kind of done a really fast and broad overview of everything that's happened. Kind of where are we going with this project? Really passionate about trying to teach people how to use Kibana and fighting the adversary. We're kind of peering into the future. We're looking to move things from Discord to Slack to make things a little bit easier. We're also going to add a Kali box and then park Prelude operator in there somewhere as well. That Kali box will allow for a little bit more unscripted and kind of free-form attack on the Windows and CentOS 7 box that are located inside this range. Some TLS fixes to Atomic Red Team are also in the work, and we are also looking at adding VMware support as well, not just using VirtualBox. We know that several people have VMware that can be used. Of course, we're going to try and keep things as updated possible, so we're going to move Elastic as a whole and Fleet to version 7.14 here soon. That should also improve the loading time and hopefully give you a much more streamlined interface in the detections app. So I've been talking for 52 minutes, roughly, and I would like to get a ton of feedback on the project. Again, PRs are welcome, but I would like to go ahead and open it up to questions on anything that we've talked about. And I've brought Sean Cochran along with me, who's a co-contributor, among many others, to help me answer any questions that I don't know the answer to. So that being said.
Yeah, so we did have a question earlier from JT, who was running into an error downloading. And Keith Wright jumped in and directed him to Slack, to the Thremulation Station Slack. So I'm guessing we probably don't want to dive into solving people's errors right here, but this is just a great plug for the Slack channel that we have the link posted to in the chat, so that as questions come up, or if you are running into errors, that's a great place for folks to go moving forward. Let's see if we have anything else so far. Well, I don't see any other questions yet. So I know, Kirk, you mentioned at the beginning of the presentation that LinkedIn would be a good way for folks to connect with you after the presentation. Is that correct? I can drop a link to your LinkedIn in the chat. I think you're on mute if you're talking to us. Sorry.
Struggling here. Sorry. Email is a good way to reach me. LinkedIn is a good way to reach me, but by far the best way to reach the widest audience for the most help is via the Slack channel and GitHub, especially if it's coding or errors. GitHub makes things easy to tie to commits. So we definitely, our preference would be put stuff in GitHub. If it needs to be a little bit more interactive, we can do stuff on the Slack channel. Again, my contact information's there, and thank you for your time, and appreciate any questions or any support. PRs are welcome.
Yeah, thanks so much, Kirk. This has been great. So thanks so much for your time and for this really awesome introduction. And thanks everyone for joining. We'll see you next time. Bye.